Hi, today I'm going to be talking to you about benign paroxysmal positional vertigo, or BPPV. We'll start off with an introduction to the balance system, including what kind of information we obtain in order to maintain balance. Then we'll be talking about the vestibular apparatus, which is located in the inner ear. We'll move on to discuss BPPV and what causes it. And then we will talk about the diagnosis of BPPV. And finally, we'll finish off with the treatment of BPPV. So starting with balance, it's very important to know where the body is positioned in space in order to be able to maintain balance. There are three tools that our body uses in order to accomplish this. The first one is through specialized receptors located in your skin, your muscles, and your joints called proprioceptors. These specialized sensors send information to your brain about where your limbs are located within space. So for example, I can close my eyes and I can position my arms in different ways, and I know where my arms are relative to my body because of these specialized sensors, the proprioceptors. Another way that we are able to maintain balance is using our eyes. Our eyes are very important for taking in the information in our environment, and they also help us orient us for where our body, specifically our head, is located in space. So for example, being able to detect that you're slightly sideways based on how the environment is oriented around you. And finally, the inner ear is a very important system that contributes to balance. It's specifically called the vestibular system. Vestibular is associated with balance. There's two types of movement that the vestibular system can detect. First is something called linear movement. And so that is movement in kind of a flat direction. So this could be side to side, this could be up and down, or forwards and backwards. And this system is activated when you're moving in a car or moving in an elevator, something that allows you to kind of move in this linear or flat direction. The other form of movement that the vestibular apparatus detects is rotational movement. And so this is an actual ability to kind of move specifically head movements in your space. And this kind of rotational movement is going to be the focus of today's topic, and we'll be using the vestibular apparatus and specifically looking at something called the semicircular canals, which are very important for being able to detect that rotational movement. Okay, so now we're going to talk about the semicircular canals. So this is a model created by vestibularfirst.com of the vestibular apparatus. And we're focused here on these tubes in these three different directions. Right now, you have one of these sitting in each one of your ears, in your inner ear. The length of one of these tubes is approximately the same as the diameter of a dime. So you can imagine how tiny this is and that it's oriented and positioned within the inner ear there. So this is the vestibular apparatus. This is the anterior portion. You see there's three tubes. They're each oriented 90 degrees from one another. And this enables the ability to detect rotation in three different directions. So you have forwards and backwards direction. You can see the movement of these little rocks to demonstrate that. You have side to side movements demonstrated here by these red movements. And then you also have left and right turning. And that occurs using these blue stones. So the green canal, responsible for forward and back movement, is called the anterior canal. The blue one here, which detects left and right movements, is called the horizontal or the lateral canal. And finally, this canal in the back here is called the posterior canal, and it detects when you're laying on your side or moving side to side. This posterior canal is going to be the main focus today because it is the canal that's affected in nearly all cases of BPPV. So each one of these canals is filled with a fluid that's a little bit thicker than water called endolymph. At the base of each tube, so at the front here, and also located here at the back, is something called the ampulla. Inside of the ampulla is a jello-like structure called the cupula. I remember this as it kind of sounds like a cup of jello, cupula. Inside of the cupula are specialized cells called hair cells. They're called this because they have little projections that kind of look like hair or fingers. When the fluid inside of the canal moves, it jiggles the jello and it causes these hair cells to bend in specific directions. And that sends a signal to your brain about which direction, either forwards or backwards, side to side, left, right, the head is moving in. So the movement of this fluid pushes those hair cells and it tells you which direction your head is moving in. So there's these little crystals that normally live in sort of the base of this apparatus, and these are called otoliths or otolithic crystals. I'll refer to them as crystals from now on. These crystals are normally responsible for that linear movement that we were talking about. They live inside of something called the otolith organs, hence the otolith crystals, and specifically something called the utricle and the saccule. And these are important, again, for that detection of linear movement. So if you were to stand up right now and spin around in a circle for 30 seconds, nonstop, and then stop immediately, you would feel the sensation of movement. And it may cause you to feel dizzy. And this is because the fluid inside of those canals is still moving due to that spinning motion, but your eyes and your body know that you're not moving. This disconnect between these two signals, am I moving, am I not moving, causes a sensation of feeling dizzy. Now this is similar to what happens to people who experience vertigo, the sensation of movement even when there isn't any. And BPPV is caused by the sensation of movement in these canals, even though there isn't movement. And like I said, this is specifically seen in this posterior canal here. So there's two things that can cause BPPV, or sort of this missent signals from the vestibular apparatus. So normally, as I mentioned, these crystals live inside of the base here. But as somebody gets older, usually around the age of 50 or 60, the wall that keeps everything kind of in one place starts to break down a little bit. And sometimes some of these crystals can come loose and work their way into the canal. BPPV can also be caused by a traumatic brain injury, such as a concussion, which causes these crystals to move out of the otolith organs and possibly into the canals. Another thing that can happen is they can stick to that jello and send the wrong kinds of signals. So when they're in the canal, it's called canalithiasis. And when they stick to that jello, the cupula, it's called cupulolithiasis. So the crystals can make their way into the canal, or they can stick to the jello. As I mentioned, in BPPV, the posterior canal is most often affected, and most often people experience canalithiasis. So the crystals working their way into the canal. So this can occur from people laying on their side, causing the movement of these crystals inside of their canal, moving the fluid, and tricking the brain into thinking that they're spinning, when in fact, they're just laying on their side. Again, miscommunication between the eyes and the body and what the ears are doing can cause the sensation of feeling dizzy. So how can this be diagnosed? Well, there is a specific maneuver, a specific way of orienting these canals called the Dix-Hallpike maneuver. Now remember, there's an important relationship between the eyes and the ears in terms of maintaining balance. I'm going to talk about something called the Vestibulo-Ocular reflex, or the VOR. Vestibular is relating to ears and balance. Ocular is relating to eyes, and reflex means something that is involuntary. So the vestibular-ocular reflex is something that's very important for stabilizing the eyes when the head is moving. So for example, if I put my finger out in front of me and I fixate on a certain point, I can move my head around and be able to maintain my gaze, maintain my focus on the one position. This is because there's communication between my inner ears telling me how I'm moving and the muscles in my eyes being able to relax and contract to stay fixated on one point. Now, why would we want to do this? Well, we spend our time navigating our environment by moving around. It is super important that we have the ability to look at something while we're moving and be able to gather information about it. So this is where the vestibular-ocular reflex comes in. The ability to maintain eye focus on one thing while the body is moving around by using our vestibular apparatus. So the Dix-Hallpike maneuver involves moving the head and the vestibular apparatus in a specific way that actually will cause reflexive movements of the eyes called nystagmus. And so this is because there's this trick of movement activating the vestibular-ocular reflex. Now, nystagmus is a patterned movement with both eyes and typically results in kind of beating or repetitive movement in one direction. Now, if nystagmus is observed during the Dix-Hallpike maneuver, it can tell a primary healthcare provider two things. First, possibly the intensity of the vertigo based on the type of nystagmus, and two, which canal is being affected based on the direction of the eye movements. So how can somebody be treated for BPPV? Well, 25% of people recover spontaneously. The crystals move inside of the ears and they manage to make their way back down into the otolith organ where they normally live. BPPV is treated non-invasively through different types of maneuvers that cause these crystals to move around and to put them back where they belong. These are called repositioning maneuvers. So in summary, balance is achieved through our proprioceptive system, that is signals sent from our skin, our joints, and our muscles about our position of our body parts in space. We also use visual information from our eyes as a cue for balance, and very importantly, information from the inner ear and the vestibular apparatus about the direction of movement, be it rotational or linear. Now, remember the semicircular canals can detect movement in 3 different directions, either forwards and backwards, left or right, or side to side, moving the fluid like so. Remember, these canals are filled with endolymph, the fluid. They have a part called the ampulla, and inside of the ampulla lives the cupula, the jello-like structure, which protects the hair cells. And these little crystals normally live inside of the otolith organs, specifically the saccule and the utricle. Vertigo, or BPPV, can be caused by 2 things: canalithiasis, which is crystals inside of the semicircular canals, or cupulolithiasis, which is crystals that are sticking to the cupula. These otoconia, or these crystals, can move from their home in the otolith organs into these areas due to the breakdown of this kind of wall or barrier, which is age-related, or it can be caused by a traumatic brain injury. BPPV can be diagnosed using the Dix-Hallpike maneuver, and what a physician looks for is a predictable pattern of something called nystagmus, or this specific eye movement. And the treatment of BPPV is to orient the head in a way that encourages the crystals to move back into their homes and out of the canal.